Hi, second year students, it's math with AUB. Let's continue our journey in the field of partial fractions, how to integrate using partial fractions. Now we are about to deal question number 2 when factors are linear and repeated. Linear and repeated. Question number 5 is 5x square negative 5x plus 2 overall x plus 1 times x minus 1 whole square. This case is known as linear as well as repeated, owing to the fact that they have power 1. Linear and different, as well as x minus 1 has a square. Linear and different, as well as repeated. As well as repeated. There are three factors involved in that. Three factors. X is equal to 1 and x is equal to minus 1. However, x minus 1 whole square is involved two times. Two times. That's why it is linear repeated and it is linear different. Linear different. We have already idea how to write the partial fraction. A over x plus 1 second, b over x minus 1 plus c over x minus 1 whole square is equal to original data whatever we have that we want to split in partial fractions, that is 5x square minus 5x plus 2 x plus 1 times x minus 1 whole square. That is the way to write x plus 1 different one. There is two repeated roots from 1 to the given power, If 3 would have been there, I have written x minus 1, x minus 2 square, then x minus 1 whole cube and so on. That is the strategy to be put in while partial fraction for repeated real roots, repeated linear real roots, taking LCM, that is x plus 1, our original determinant, x plus 1 times x minus 1 whole square, a times x minus 1 whole square plus b times x plus 1 and the bracket x minus 1, c times x plus 1, and this, pass me the duster, let me write in a good space this one, okay, LCM x plus 1 times x minus 1 whole square, whatever with ln, whatever with a, x plus 1 to be vanished out, take the rest denominator x minus 1 whole square plus b. Whatever is the denominator of b, that is x minus 1, we have to take x plus 1 and 1 times x minus 1, x plus 1 as well as x minus 1 plus c, whatever with c has denominator x minus 1 whole square, missing this, taking this, c times x plus 1 is equal to 5x square minus 5x plus 2 overall x plus 1 x minus 1 whole square. Shifting this quantity on the right hand side, this quantity from denominator to left hand side, they are cancelled out. They are entitled to be cancelled out. Saving space and time, cancel them out. What remains? Let's see, a times x minus 1 whole square plus b. If we merge them, it will become x minus 1, x square minus 1 plus c times x plus 1 is equal to 5x square minus 5x plus 2. We okay, just multiply brackets and compare x square coefficient of x and constant along with the tip that to be discussed now, how to solve complicated system. Bx square minus b, cx times plus c is equal to 5x square minus 5x plus 2. Here multiplying throughout, we have ax square to ax plus a. We have already done this, bx square minus b, cx plus c is equal to 5x square minus 5x plus 2. Collecting the like terms, square, ax square, bx square, then x, having x, this is also x, minus 2 times ax plus cx. Constants, a, negative b and c, plus a, negative b plus c is equal to how much? 5x square minus 5x plus 2. Taking x square common, we have a plus b. Taking only x common, we have minus 2a plus c. This is a constant. A minus b plus c is equal to 5x square minus 5x plus 2. 5x square minus 5x plus 2. Comparing, coefficient of x square is equal to coefficient of x square. A plus b is equal to 5. Minus 2a plus c is equal to minus 5. And the constant, that is a minus b plus c, is equal to 2. Comparing. Let me make a space. Okay. On comparing, our first equation is a plus b is equal to 5 by virtue of the coefficients of square terms. A plus b is equal to 5, equation number 1. What about x? Coefficient of x here, minus 2a plus c here, minus 5. Second equation is minus 2a plus c is equal to negative 5. Good one. What about constants? A minus b plus c is equal to what? A minus b plus c is equal to 2. A is equal to 2. Look at this one. We have 3 equations. It is something like complicated, cumbersome. We have to switch over to row operation, either Gaussian elimination method or Gauss-Jordan method. But take the assistance of this equation and utilize a root also. In this case, at the starting we have 2 different roots, that is x is equal to minus 1 as well as x is equal to 1. They works wonder for us in this equation. Let me put x is equal to 1 in that. Put x is equal to 1. 1 minus 1, it is cancelled out. 2 cancelled out. It will give me something value of c, that is c 1 plus 1. Put x is equal to, it is no more, something like there. 1, it will become 5. I am putting x is equal to 1 from this equation. 5 minus 5 plus 2 cancelled out. What I have? C2 times 2. C is equal to 1. Bingo! This little hole, this value of C makes a little hole in this system and it is about to collapse. Let's see and find out how. What is the value of C? 1 we have generated. Put here minus 2a. Value of C is 1 is equal to minus 5. Shift 1 over on the right hand side. Minus 5 minus 1. Minus 2a is equal to minus 6. Then a is equal to 3. We have value of a. Put in that equation. We are going to get b as well. A plus b. Put a is equal to 3 in that case. 3 plus b is equal to 5. So b is equal to 5 minus 3. B is equal to 2 in that case. B is equal to 2. So value of b is 2. Value of a is 3 and value of c is 1. Put these. Oh, what I have done, how I have written. Let me manage the show. I can manage. I have written something like this. A times dx over x plus 1 plus b dx over x minus 1 plus c dx over x minus 1 whole square. Okay. Value of a I have 3. 3 dx over x plus 1. B 2 times dx over x minus 1. C is minus 1. It's dx over x minus 1 overall square. It is famous case of ln. Differentiation of x is 1. Overall power is 1. Function derivative function in the denominator ln situation. So does here. Differentiation of x is 1. Overall power 1. ln. This is not the ln situation. It has power 2. It should be brought to numerator. It is 3 times ln x plus 1 plus 2 times ln x minus 1. It is the case of simple integration. Shift the function in the numerator and add 1 into it. X minus 1 whole square minus 2. It will become minus 1 divided with the same. 3 times ln x plus 1 plus 2 times ln x minus 1, adding 1 into the power, it will become minus 1. Settling it down, positive, negative, positive, positive, negative, positive, turn the exponent from negative to positive. I have this thing 3 times ln x plus 1 bracket over plus 2 times ln x minus 1 over x minus 1 plus c. It's your answer. Or you can make these coefficients as power utilizing the power of property of ln in that case, then positive 2 ln's into multiplication. You can do that, or you can leave this answer here. I have given you idea several times. Okay, moving further, moving one step further. What I have, it is also simple. The next question is 9x square plus 3x plus 29 over x plus 1 divided by x square minus 4. X square minus 4. Check this one. There is minus 4 or plus 4. Check the situation, this one. I think it is quite an irreducible case. There is a positive sign. Check. Give me the book. Pass me the book. Plus. It is plus. Okay, we are good because we have already pasted these equations, posted these equations, pasted as well. Okay, question number 2. That is now question number lump sum 6. Today's second. 9x square plus 3x plus 29 divided by x plus 1 x square plus 4 dx. Now look at this on the outside. Let me tell you, good idea. If you multiply them throughout, it will become x cube. It will become x cube. It is not a function derivative situation. It is not a function derivative situation. If it is not a function derivative situation, degree of denominator is greater than numerator. Degree of denominator greater than degree of numerator. It is possible case of partial fraction. Partial fraction. Let's see and find out. Here it's linear and different. There is one root. It is quadratic irreducible in R. It is quadratic irreducible in R, and we are dealing in our second year overall real valued function. Real valued function. If we have complex valued function, then it is also reducible. How? Let's see. X square plus 4. It can be written as, instead of iota square, I can put minus 1 minus 1 plus factorize this. It will become x plus 2 iota, x minus 2 iota. It is reducible in complex. It is reducible in C. It is reducible in C, but not in R. But not in R. So we are dealing with R real numbers. It is quadratic irreducible. For us, it is quadratic irreducible. Now linear plus quadratic irreducible. Quadratic irreducible factors. How to write their partial fraction? Let's see and find out. It is simple one, linear. A over x plus 1 plus b. This one can be written as bx plus c. Bx plus c divided by x square plus 4 is equal to 9x square plus 3x plus 29 divided by x plus 1 times x plus 4. Okay. Look, there might be a difference of 1. There is x. There is no x, means x power 0. Look at this. There is x square, there is x power 1. In partial fraction, the difference of the degrees between numerator and denominator must be 1. Must be 1. Must be 1. Look at this. This is 0 and 1. Good. This is 1 and 2. This is 1 and 2. That is the idea behind quadratic irreducible partial fraction. If something is present like this, x cube plus 7, how to write its partial fraction? Then it can be written as ax square plus bx plus c divided by x cube plus 7. That's the partial fraction of that thing, x cube plus 7. So the degree difference between numerator and denominator must be 1. Must be 1. Must be 1. Must be 1. That is the term. Similarly, one can write the partial fraction for x plus 4, x plus 4 plus 5 as ax cube plus bx square plus cx plus d, and answer. Similarly, one can write for x power 5 plus 1 ax4 plus bx cube plus cx square plus dx plus e. When further factors are not possible. When further factors are not possible means The expressions are irreducible, 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 irreducible in R, irreducible in real numbers, real numbers. In complex number, they can be factored out. We are dealing real numbers. According to real number, they have no real solution. That's why we have done applied so quadratic irreducible. That the study behind quadratic irreducible. Difference of degree between numerator and denominator is 1. Is 1. Is 1. Okay, find the values of A, B, and C. Taking LCM, x plus 1 times x square plus 4 here, A times x square plus 4, bx plus c times x plus 1, it is equal to 9x square plus 3x plus 29 divided by x plus 1 times x square plus 4. This denominator cancelled out. We have good idea about this. Merging them and multiplying, we have ax square plus 4a. It will become bx square. With this, it will become bx. We are multiplying the brackets, plus cx plus c is equal to 9x square plus 3x plus 29. It's our answer. Collecting the like terms, first x square, then x, then whatever. Collecting the like terms, ax square plus bx square plus bx plus c, x square, then x, then without x. 4a plus c is equal to 9x square plus 3x plus 29. Now taking x common and comparing, x square common, sorry, we have a plus b. Taking x common, b plus c. In that case, constant 4a plus c is equal to 9x square plus 3x plus 29. Comparing the like terms, coefficient of x square is equal to coefficient of x square, means our first equation a plus b is equal to 9. Second, b plus c is equal to 3. Third, 4a plus c is equal to 29. 4a plus c is equal to 9. Three different equations involving a, b and c, a, b and c. They are going to give us good tough time, but utilize your concept from here. From here, I have already told you, put a value of x, and you are going to get through. Let's see how. Okay. From here, we are left with, prior to this multiplication, we are left with here a x square plus 4 plus bx plus c times x plus 1 is equal to 9x square plus 3x plus 29, something like this and that. Now look at this. What is our original denominators? These are solve. X plus 1 is equal to 0, x is equal to minus. The other will give us the imaginary roots. We are not, just x is equal to minus 1. A little opening in the rock, in these three brackets works wonder for us. Then they are going to smash to their values simply. Put x is equal to minus 1 here. X is equal to minus 1 plus 1, it has been cancelled out. No more. Here what we have, a minus 1 square plus 4, it's our 0. A is equal to 9 times minus 1 square plus 3 times minus 1 plus 29. How much it is? Negative 1 square means positive 1. 1 plus 4, it will become minus 1 square means positive 1. 9 1 the 9 minus 3 plus 29. It will become 5a. Here, how much? 6. It will become 25. 9 minus 3 6. 6 plus 29 25. A is our 25 over 5. Bingo! We have done our task. The rest is a piece of cake. A walk in the park. Put value of a here. A plus b is our 9. Utilize a is equal to 5. Then b is our simply 9 minus 5. Value of b is 4. Impressive. What about c? Put value of b here. B plus c is equal to 3. Value of b is 4. 4 plus c is equal to 3. Then c is equal to 3 minus 4. C is equal to minus 1. We have the values of all unknowns that we need. Let me write here in a fashion to put to the values. A is equal to 5, B 4, C is equal to minus 1. Okay, try to now integrate. I have something like A times dx over our first bracket is x plus 1. Thanks God. Plus, I have written here bx plus c over x square plus 4 dx. Value of a 5. 5 integrate dx over x plus 1. It is function overall power 1 differentiate in the numerator 5 times ln x plus 1. We have done with this. What about this? Value of b? b is 4. 4x plus value of c is minus 1 overall x square plus 4 dx. Still we have to grind the con to solve this, but it's simple one now. 4x minus 1 divided by x square plus 4. If you recall the situation that we have done somewhere in your 3.1, I think 3 x square something like this had been present, we have done so, dividing separate function derivative and tan inverse situation. We have done, you can recall. I am doing this again here, don't you worry. 5 times ln x plus 1. If I divide separately, 4x divided by x square plus 4 and minus 1 times dx divided by x square plus 4. Look at this. X square, differentiation of x square is 2x. Differentiation of x square is 2x. It is present. Overall power 1. It is ln situation. It is ln situation. Just we have to split this as 2 times 2. 2 times 2. 5 times ln x plus 1. Let me write this as 2 times 2x dx over x square plus 4. What about this? Settle down the situation. It is x square plus, instead of 4, let me write 2 square. X square instead of 4, 2 square. Instead of 4, 2 square. Now everything is wonderful. What is integration of this one? Dx over x square plus a square. Let me give you a good idea. 1 over a tan inverse of x over a. Here instead of a we put 2 here, 2 here. It's our answer. It's our 5 times ln x plus 1 plus 2 times its function derivative having overall power. It is also ln 2 times ln x square plus 1 minus. It is equal to 1 over a tan inverse of x over a. Instead of a we have to write 2 plus c. It's our final answer. It's our final answer. It's our final. Look at the strategies. Partial fraction, linear along with quartic irreducible. Quartic irreducible result in function derivative situation as well as magic substitution x is equal to a tan theta. Look at the depth of a single question. Single question. Moving towards question number 7. Again, linear and quartic irreducible both are collectively present here. Let's see and find out how to deal them. We can. Question number 7. Humongous one. 7x square plus 7x plus 4 divided by 2x plus 1 times x square plus x plus 1 dx. Oh God. Let's see and find. Same literature verifies this. 2x x, it will become x cube. There is no function derivative situation, partial fraction. It cannot be factorized further in real numbers. It is quadratic irreducible in real numbers. It is quadratic irreducible in real numbers. However, it is, we can generate cube from here. Cube, if you are familiar from your first year, cube, omega cube is equal to 1, 1 plus omega square is equal to 0, and cube roots form multiple cyclic group under addition. At your book levels, it has been written that it is abelian group with respect to multiplication. Not to go there, just stuck to whatever we have. A times first factor is linear, good one. Second one is quartic irreducible, quartic irreducible, quartic irreducible. That is the strategy, bx plus c divided by x square plus x plus 1, because the degree difference must be 1 in case of partial fraction. This one same, 7x square plus 7x plus 4. I think that is the case. 2x plus 1 times x square plus x plus 1. Okay, taking LCM, here what we are left with, x square plus x plus 1 plus bx plus c times 2x plus 1 is equal to 7x square plus 7x plus 4 dividing with 2x plus 1 x square plus x plus 1 and 2x plus 1 times x square plus x plus 1. You are familiar, there must be no more, just multiply and wait the situation, settle the situation. It will become ax square, ax plus a, multiply a throughout, multiply these two, it will become 2bx square plus bx, 2cx plus c is equal to or 7x square plus 7x plus 4. Oh God. Look, ax square plus x plus a bx square 2bx square plus bx 2cx plus c. Good one. Collecting the like terms, ax square plus 2bx square. Then having term x. Oh, good. ax plus bx plus 2cx. Oh God. What about constant? A plus c is equal to 7x square plus 7x plus 4. Taking x square common, we have a plus 2b. What about this? X common, we have left with a plus b plus 2c. Continuing our journey, let me write this one here. 7x square plus 7x plus 4 in order to generate space, plus a plus c is equal to 7x square plus 7x plus 4. Comparing the coefficient of x square, a plus 2b is equal to 7, a plus b plus 2c is equal to 7, a plus c is equal to 4. Let's see and find out what we have. A plus 2b, it's our 7. Second is a plus b plus 2c, it's our 7. Next, a plus c is equal to how much? 4. A plus 2b, we have again a system of 3 by 3, 3 by 3, but from here, if we can manage a single value from here, that is x is going to be minus 1 over 2, x is going to be minus 1 over 2, this will give us good cushion, utilizing this fact and moving further. Okay. Putting x is equal to minus 1 upon 2. If I put x is equal to minus 1 upon 2, here 2 times minus 1 upon 2 plus 1 cancelled out, it will become 0, overall 0. We are left with this. Put x is equal to minus 1 upon 2 in that case. A minus 1 upon 2 whole square minus 1 upon 2 plus 1 is equal to 7 times minus 1 upon 2 whole square, 7 times minus 1 upon 2 plus 4. Let's see and find out what we are going to have. Okay, it will become a 1 over 4 minus 1 upon 2 plus 1 is equal to 7. 7 into 1 upon 4 minus 7 over 2 plus 4 a. In that case, 4 is our LCM, 1 minus 2 plus 4. 4 is our LCM, 1 minus 2 plus 4, we are good. Here, 4 is our also LCM. It will become 7, 2 7 the 14, 4 4 the 16, 4 LCM. Only 7, 2 7 the, no more. 4 4 cancelled out. What we have left with? 1 and 4, 5 minus 2, it's 3. Here, 7 and 16, how much? It will become how much? 7 minus 14, 16 minus 7. 16 minus 7, how much? 9. How much? 9. We are left with 9. 16 minus 7, it's 9. 1. Okay, good. Then A is going to be 9 over 3. So value of A is 3. Bingo. We have tumbled over the giant. Put value of A is equal to 3 here. We are going to get something 3 plus 2 times B is equal to 7. 2B is equal to 7 minus 3. 2B is equal to 4. B is equal to, good. Put in that equation to get C. It's simple one. A plus C is equal to 4. Or A is 3. 3 plus 3 is equal to 4. C is equal to 4 minus 3. C is equal to 1. We have all the values. Now A is equal to, what is A? A is 3. What is B? That's 2. What's C? It's 1. Good one. 3, 2, 1 in descending order. 3, 2, 1. Now let's reconcile these values and integrating to find what is our answer. I have done so like dx over 2x plus 1 plus b times x plus c moving to quadratic irreducible plus 1 times dx. Mine is 3 times dx over 2x plus 1. Let me deliver a speech on this. I have already told you differentiation of 2x is 2. The efficiency of 2 divided and multiplied by 2 having overall power 1. Settle it down. Dividing and multiplying by 2. We have 2x plus 1. I am writing for you to give you comprehensive clarity. It's case of ln. 3 over 2. ln whatever the function present in the denominator. What about this? Let's see. B is 2, 2x, good one. C is 1. It's also simple one. X square plus x plus 1. Function derivative. But differentiation of x square is 2x. Differentiation of x is 1. Thanks God. It is going to be ln x square plus x plus 1 plus c. It's our answer. It's also same ln x square plus x plus 1 plus c. That's our answer in that case. Quadratic irreducible, whatever the case is. Finally, if you look at this question, our story further expands. X cube divided by x square. The degree of numerator is greater than denominator. It is case of synthetic division. First, apply synthetic division. Make the degree of numerator lesser than the denominator. Then you are in a position to apply partial fraction on that. Mark my words. If the degrees of both numerator and denominator are same, apply synthetic division. If the degree of numerator is greater than denominator, still synthetic division. Look at this. X square plus 1, synthetic division. If degree of numerator is greater than degree of denominator, synthetic division. These both are the cases of synthetic division. Mark my words. Synthetic division. When to apply synthetic division? If the degree of both numerator and denominator are same, or degree of numerator is greater than denominator. So does the case here in question number 8. Let's see and find out how to unfold this, how to make this fall. We have x cube plus 4x square plus 9x plus 14 divided by x square plus 4x plus 3 dx. Degree of numerator is greater than denominator. First apply synthetic division to make the degree of denominator greater than numerator. Apply simple synthetic division. Mine won the orthodox method. X cube 4x square plus 9x plus 14 divided by x square plus 4x plus 3. Divide first with first one. X cube divided by x square. We have x right here. X times x square, it will become x cube. X times 4x, it will become 4x square. 3 times x, it will become 3x. Subtract. Cancelled out. 9x minus 3x, we have 6. x plus 14. It is our quotient. How many times applied we have applied table at x time? What is the remainder? That's our remainder 6x plus 4. That is our divisor and it is our dividend. It is our dividend. Writing style is this: quotient plus remainder divided by divisor. Quotient plus remainder over divisor. Quotient plus remainder over divisor. That is the strategy to write after strength reading. Our quotient is x. Most welcome. Our remainder is 6x plus 14 divided by x square plus 4x plus 3 and dx. It is x1. Its integration is simple. Its integration is given by x square over 2, x square 2. The rest we have put this one to solve. We have to put this one to partial fraction. Now we can, because degree of denominator is greater than numerator. It is no simple type of function derivative situation. We can put this to solve by applying synthetic deviance, partial fraction. Let me write them in partial fraction. Oh God. Let me make a space. Okay. I have here. This write x square upon 2 and forget. Take only this 6x plus 4 for the time being, divided by factorizing this x square 3x plus 1x plus 3. 1 times 3 is 3, 3 plus 1 4, middle term breakup. We have 6x plus 14. One bracket is x common, x plus 3 plus 1 common, other bracket is x plus 3. So we have something like this: x plus 3 times x plus 1 dx. Now apply partial fraction. A over, pass me the pen having ink. A over first bracket, linear and different is the case. B over x plus 1 is equal to 6x plus 14 divided by x plus 3 times x plus 1. X plus 3, x plus 1. Thanks. It will become a times x plus 1 plus b times x plus 3. We have 6x plus 14 divided by x plus 3 and x plus 1. Cancelled out. Let me erase this side and manage the normal partial fraction. Here x square over 2 present. We can compensate this right again. Now we have this situation: a x plus 1 plus b times x plus 3 is equal to 6x plus 14. Multiply and compare. Simple case for obtaining values 3b. It is 6x plus 14. Collecting the like terms, ax plus bx, a plus 3b is equal to 6x plus 14. Taking x common, making life simple, it will become a plus b. It is a plus 3b. It is equal to 6x plus 14. Comparing the like parts, a plus b is equal to 6, equation 1, and the second one is a plus 3b is equal to 14. Look at the simultaneous linear equation types. Just subtract. We are going to have minus 2b. It will become minus 8. So value of b is 4. Cancelling out, plus b minus 3 minus 2b plus 6 minus 14 plus 6 minus 14 minus 8. B is 4. Put in an equation. Let me put in that. A plus b is equal to 6. A, what is b? That's minus 4. Solve for a. 6 minus 4. A is 2. Value of a is 2. Value of a is 2. Now I can manage a over dx divided by x plus 3, b divided by x plus 1 dx. Okay, for complete question, don't forget to write, include our quotient is x, integration of x is x square over 2. This one, value of a is 2, it is dx over x plus 3. Value of b is 4, dx over x plus 1. It is the same case of ln having overall power 1, 1. Differentiation of x is 1. Function derivative overall power 1. Function derivative overall power 1. X square over 2 plus 2 times ln x plus 3 plus 4 times ln x plus 1 plus c is our answer. Is our answer. If you want to show your more skills, these power can be converted as coefficient can be converted to powers. Then multiply ln a plus ln b as ln a times b, ln a times b, or leave here. It's my tiny effort for you guys to give you good idea what do you mean by partial fraction. What do you mean by partial fraction? What I have next for you, the remaining, I think 4 questions from 9 to 12, 9 to 12, and they are not simple one, and they are not simple one. It's all by itself. Next.